Okay, so let's look at some exponent review practice. So if we have multiplication and we have powers of the same base, then we add the exponents. So if I have powers of the same base, I'm going to add the exponents. If we are dividing powers of the same base, we will subtract the exponents. If I do power to a power, it means I will multiply the exponents. And if I have the power of 0, the answer is 1. Okay, so I want to simplify the following using exponent laws, which means I need to use the exponent laws, but I also need to follow BEDMAS. So I'm going to do the brackets first. So if we're going to multiply powers of the same base, we're going to add the exponents. So I'm going to get x to the power of 15. And I'm going to do brackets again. I'm going to multiply because we have a power to a power, so I get x to the power of 15 again. When you divide powers of the same base, you will subtract the exponents. So 15 minus 15 is 0. So I'm going to get x to the power of 0. And x to the power of 0 is just 1. Okay, so I have a monomial to the power of 4, which means I need to do 7 to the power of 4, a 10 to the power of 4, and b to the power of 4. So 7 to the power of 4 is 2,401. When we have a power to a power, we're going to multiply. So I'm going to get a to the power of 40, and I'm going to get b to the power of 4. Again, I want to do brackets first. So I'm going to do inside the brackets first, and then I'll worry about the outside exponent second. So I'm going to do 70 divided by 35, which gives me 2. I have x25 divided by x20. So when we subtract powers of the same base, when we divide powers of the same base, we're going to subtract the exponents. So I'm going to get x to the power of 5, and that's all to the power of 10. So now I have 2 to the power of 10 and x5 to the power of 10. So 2 to the power of 10 is 2 to the power of 10 is 1,024. And when we have a power to a power, we're going to multiply, so I have x to the power of 50. Okay, if we look at this one, we have a square-based pyramid. So that means that the bottom is a square and it comes up to a point. The base length is 3 to the power of 100 millimeters. And the height is 3 to the power of 58 millimeters. We want to determine the volume of the square-based pyramid as a simplified power. So they've given us the formula for the volume of a square-based pyramid. So I'm going to write that down. So I'm going to say, well, the volume is b squared times h divided by 3. So the base length, which is my b, is 3 to the power of 100. So I'm going to replace b with 3 to the power of 100. But b is to the power of 2, so this must be to the power of 2. H is my height, so my height is 3 to the power of 58. So I'm going to replace h with 3 to the power of 58. And then this is all divisible by 3. So I'm going to do the exponent on the outside of the bracket first before I do multiplication or division. So So if I have a power to a power, I'm going to be multiplying. So this is 3 to the power of 200 times 3 to the power of 58. And that's all divided by 3 still. So now I can multiply. So I have powers of the same base. When I multiply powers of the same base, I can add the exponents. So that gives me 3 to the power of 258 divided by 3. And this is really like 3 to the power of 1. You can put the exponent there or not as you choose. And when I divide powers of the same base, I'm going to subtract. So I'm going to subtract 358 by 1. So I get, 258 by 1, so I get 257. And because we were looking for the volume, and the volume was in millimeters, it will be millimeters cubed. So therefore, the volume of the pyramid is 3 to the power of 257 millimeters cubed.